Good afternoon, my dear students. I am glad to see you. How are you? How are you?
We are fine, thank you. And you?
Thank you.
Thank you. I'm okay. Are you ready for the lesson?
Yes.
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 Okay. Let's start. Let's start our lesson. Who is absent today? Who is absent? Absent is Eldar and Araylan. Okay. Start. I would like to start with the phrase "work hard, dream big." I think you understand this phrase and always do this.
Recording in progress.
Play the game. What's the homework? What was the homework? Please.
Dropping.
Play the game, please.
Homework was learn terminology words
from past lesson.
Okay. Thank you. We start. We start homework. Eldar, өшіріп қойсаңыз. Eldar, өшір. Everything here, it's wonderful. We start our lesson. I have a nice day. I test your knowledge through the game chain. The first say his word, and the second say the first word, and say his word. So we continue. Please start, Amir, first. Terminology. Dropping. Okay. Second, Perizat.
Dropping. Logic gates.
Logic gates. Okay. Third, Eldar.
Dropping. Dropping. Logic gates and intuitive.
Okay. Звук өшір, Eldar. For Arsen. Okay, next 5, Araylan. Anwar, 6. Anwar. Ramilia.
Logic, dropping, logic gates, intuitive, drag and drop.
Okay, next, Ramilia.
Dropping, logic gates, intuitive, and otherwise.
Okay, great job. And Altnay? Altnay, please.
Is dropping, logic gates, intuitive, and drag and drop otherwise. It identified.
Ayaolam? Finished our terminology.
Dropping, logic gates, intuitive, drag and drop, otherwise, identified, and and not or gates.
Okay, good job. Thank you. Next picture. What do you see in the picture, please? First picture and the second picture. Who can answer?
ASCII character codes, binary,
Prenatal
octal,
is English.
Okay, okay.
decimal,
Else?
and symbol.
Who can else answer? Two.
In the first picture, we see symbols and ASCII character codes and symbol and octal, binary, and something else.
Okay. First question. What do you think the term our lesson, the topic our lesson?
I think that today we learn about Unicode
ASCII,
and ASCII.
Encoding and
okay.
decoding.
What do you think the purpose of the lesson? Who can answer? Purpose of the lesson.
I think that we purpose you maybe decoding and coding Unicode and something else.
Okay. Great
discover
answer.
between ASCII and the Unicode.
Thank you. Please open the copybook and write our topic, encoding standards, please.
Okay.
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 You are right. Answer our topic, encoding standards, and in the topic we compare encoding and decoding ASCII and Unicode. The purpose of the lesson, please. You get acquainted with the methods of coding and decoding of textual information with the help of coded tables and the computers. Compare encoding standards, Unicode and ASCII. New terminology. Listen carefully. I read terminology. First, encoding, kodtau, decoding, decodtau, character, символдар, nevertheless, дегенмен, compare, салыстыру, punctuation, пунктуация, conversion, түрлендіру, uppercase, басарып, lowercase, кішарып, widespread, кең таралған. Who can answer or who can read? Who can read after me?
Me, encoding, decoding, character, nevertheless, compare, punctuation, conversion, uppercase, lowercase, and widespread.
Widespread. Widespread.
Widespread.
Mistakes. Okay, who can to read once?
Encoding, decoding, characters, nevertheless, compare, punctuation, conversion, uppercase, lowercase, widespread.
Okay, thank you. Enough. Next question. How do computers understand any human language? Please, who wants to answer?
ASCII can understand uppercase and lowercase, alphabetic characters, number, punctuation marks, and common symbols.
Okay.
Yes, and they understand symbol 1 and 0.
Okay, okay, great answer. Thank you. Our topic, encoding and decoding. Encoding is the process of converting some characters, letters, punctuations, numbers, certain symbols into a format can be understood our computer. Decoding is the opposite process. Conversion of encoded format back into the original characters. ASCII. ASCII is the code used by most computers for encoding is known as ASCII, American Standard Code for Information Interchange, pronounced ASCII. ASCII can understand uppercase, lowercase, alphabetic characters, numbers, punctuation marks, and the common symbols. Next page. Unicode vs ASCII. ASCII and the Unicode are different encoding standards. The main difference between them is in the way how they encode the character and the number of bits. ASCII originally used 7 bits to encode each character. That was later increased to 8. In contrast, Unicode uses a variable bit encoding program where you can choose between 32, 16, and 8-bit encodings. Using more bits lets you use more characters, but large files at the same time, while fewer bits give you a limited choice, but you save a lot of space. The major advantage of Unicode is that it can encode a huge number of characters compared to the ASCII. Because of this, Unicode currently contains most written languages and still can have even more. Okay, first question. What is encoding? Who can answer? What is encoding? Amir, please.
Encoding is the progress of converting characters.
Okay, okay. Who can else answer? Encoding is a process.
Encoding is decoding and is a process opposite the conversion of encoded format back into the original characters.
Okay, thank you. Decoding, it is opposite process. Okay. Next questions. What is between what is difference between Unicode and ASCII? Who can answer?
Unicode
Between them,
then
Unicode,
uses 7 bits and the Unicode uses
ASCII use 7 bits. Unicode use more bits than ASCII. Unicode use 8 bits.
Okay, okay, good job. And Ramilia, please answer. Ramilia, start answer.
Originally, ASCII used 7 bits and Unicode used 16 or 8-bit encoding.
Okay, okay, thank you. Next page. In order to be compatible with the older ASCII, which was already in widespread use at the time, Unicode was designed in such a way that the first 8 bits matched the ASCII table codes. So if you open an ASCII encoded live with Unicode, you still get the correct characters encoded in the file. This provided the adoption of Unicode as it decreased the impact of adopting a new encoding standard for those who were already using ASCII. Summary, ASCII uses an 8-bit encoding while Unicode uses a variable bit encoding. Unicode represents most written languages in the world, while ASCII doesn't. Third, ASCII has its equivalent within Unicode. Keep in mind, other commonly used codes include Unicode bin hex, Unicode, and MIME. In data communications, Manchester encoding is a special form of encoding in which the binary digits represent the transitions between high and the low logic states. In radio communications, numerous encoding and decoding methods exist, some of which are used only by specialized groups of people. The oldest code of all originally employed in the landline telegraph during the 19th century is the Morse code. Next question, what is the oldest code? What is the oldest code in our topic?
The oldest code, it's Morse code. It's during the 19th century.
Okay, okay, you are right. Let's look at the video about encoding standards. Көрініп тұр ма видео или жоқ, слайд тұр ма?
Google'дың несі тұр ағай?
Я сайтта тұр.
Презентациядан шықты.
Listen carefully.
Okay.
Okay.
Окей. Әлі қосылмады ағай.
Загрузка. И онда біз былай істейік. Let's solve tasks on the topic.
Okay. Okay.
Okay.
Task 1. Look at the task. Look at task 1. The automatic device has transcribed an information message in Russian with a length of 20 characters, originally written in a 2-byte Unicode code into an 8-bit COI8 encoding. How many bits have the message length decreased? In the answer, write down only the number. Start. Solution.
Okay.
And give 3 minutes. Who decided to send task to WhatsApp? Send your
Okay.
solution WhatsApp. I'll check, and I left comment who has mistakes. There are
Okay.
I think your solution this task
Okay.
to solve task.
Окей.
I send it.
Send it. Okay. Minutes. I want to open this video.
I send it to.
Okay, Ramila, send
Ikide sonda çıktı.
it. No mistakes, Ramila. Good job.
I finished it.
And the Pirizat. Ayalım. Okay, okay. No mistakes. Okay. I show you a solution. First, with 16-bit encoding, the message size is 16 multiply 20 bits. Second, when it was recorded into an 8-bit code, its volume became equal to 8 multiply 20 bits. And the third, thus the message decreased by 16 multiply 20. And the answer 160 bits.
116.
Okay, I'm showing. You are right, especially you are work hard. Altanay, Ayaulam, no mistakes. Anwar, 1 mistakes. Amir, 1 mistakes. And next. Task 2. Task 2 enclose the ASCII code with the word Moscow. Let's make a table and place the word Moscow. Using the ASCII code table, we encode all the letters of the word. The table, you ASCII table. You look.
Okay.
Okay.
Hareket çatam.
Do you understand me? Do you understand me? Amir? Amir, do you understand
Yes.
me?
Okay.
Yes.
To solve this task. Eldar, звугыңды өшір. Eldar, звук өшір. Так.
I send it.
Okay.
I send it.
Altama, send it.
I send it.
Okay, Alt9. No mistakes. Good job. And Ramila. Yeah, Amelia, you are okay. You are right. Right. Solution. Altınay, Ayolum, right answer, right solution. Please, who can answer solution? Who can answer?
One
Please, in English.
0 0 1 1 0 1 1 0 0 1 1 1 1 0 0 0 1 1 1 0 0 0 1 1 1 0 0 1 1 1 1 1 1 1 0 1 1 1.
Okay, okay. You with we use table, ASCII table. Here, decimal, octal, char, binary, and characters. Okay. Мысалы, for example, A 65, B 66, M 77, O 79 in decimal, in hexamal, in octal, and char. You are use these alphabet characters and to solve this task. Okay.
Yes,
Okay.
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 Look at the video. Please. Listen carefully.
Terms ASCII and Unicode for the GCSE Computer Science course. We already know how to convert ordinary decimal numbers into binary code. We simply take the 8 place value columns from the binary table, identify which of those numbers we need in order to add up to the total, in this case of 182, and then put ones under each of those numbers, filling the remaining columns with zeros. But how can we do the same thing for letters? We understand numbers can become numbers, but how do we turn letters into binary numbers? Every single key on your keyboard has a number associated with it. Every single character that you can type can be translated in a decimal number. For example, the character capital A on your keyboards becomes the number 65. This is the standard and is globally recognized. It's part of the ASCII table. Every letter, every symbol, and every number on your keyboard has a corresponding number associated with it. So A is always 65. ASCII uses 7 bits. In other words, the binary numbers representing these letters have 7 bits to them. So we use these 7 columns to create a possible 127 different numbers, each of which has a number, letter, or symbol associated with it. So if we take 7 bits like this, we can create a binary number using 64 and 1 to create the number 65, which represents A. So this is the binary representation of the letter A on your keyboard. With 127 different possible numbers, we can represent all of the uppercase letters, all of the lowercase letters, all of the digits 0 to 9, as well as a wide range of symbols. Additionally, there are also commands on your keyboard that are also represented by binary numbers. The backspace button, the escape, tab, the enter key, and also the delete button, which actually is the number 127, the maximum that ASCII can represent. However, there is a problem, because whilst these 127 different symbols and characters seem fine, they fall far short of the number of characters that we often need to represent. These languages, for example, are not represented in standard ASCII. In a growing range of emojis. So just to recap then, ASCII is an encoding system for letters on your keyboard that uses 7 bits. We can use an 8th bit occasionally, which we call extended ASCII, which doubles the number of possible characters, although that's still far short of what we need for the full set of languages and symbols that we use. Unicode is the same thing as ASCII for the first 127 symbols or characters. And Unicode can support far more characters by using 8, 16, or even 32 bits, which would allow support for 2,147,483,647 different possible characters. That's a lot of emojis.
Okay. Who can answer? What about this video? Please.
About this video, we learn about different Unicode and ASCII and how we used ASCII and Unicode as symbols.
Okay.
Example and about ASCII.
Who can else? About video.
Unicode represents most written language in the world, and ASCII has its equivalent in Unicode. The difference between ASCII and Unicode is ASCII represents lowercase letters, A to Z uppercase letters and digits 0 to 9, and symbols such as punctuations, marks, while Unicode represent letters to English and other language.
Okay, okay. Thank you. Good answer. Right answer. Give me feedback. I sent you link to WhatsApp. Open the WhatsApp. 1 minute.
Okay.
Give me feedback. Open the link, write the name, and please write you are excellent, good, back. Our topic. And please chat, use chat, write the chat. You are very active, clever. Especially. Okay. Minutes.
Оптимальный.
Көрейік. Бізде балалар запись 40 минут, 40 minutes. Сондықтан бізге қазір жалпы уақытымыз бар. 5 минут егер сыныпта болғанда бізде 5 минутқа ойын ойнауға болар еді. Quizzes, the game is quizzes. Ол ойын дайын тұр. Бірақ қазір біздің уақыттың тығыздығына байланысты бұл ойынды жаңағы кейін ойнаймыз. Міндетті түрде мен сендерге жіберемін. Қазір біздің жаңағы фидбактарды көрейік.
Жақсы, окей.
Okay.
Ашылмай тұр. Қазір өзіне көресің. Окей. Барлықтарыңыз түсініпсіздер. Everyone understand the topics. Excellent. Thank you. Lesson is over. You are very clever. You are very active today. Especially Ayağulım, Altınay, Ramila, Anwar. Thank you. Thank you for the lesson. Thank you.